All right, welcome everyone. I'm Dániel Mohácsi. Thank you very much for coming. To repeat, I hope you had a great lunch. I'm going to talk about performance testing. And before going into that, I would like to make some statistics for myself. So I would like to ask you to raise your hands if you are working in on-call. So you have to pick up the phone over the night if something bad happens with your system. Good. We have a few. Okay, and are there any testers in the audience? Please raise your hand. No? Okay, so let's jump right into it. I'm working at Origoss. Yeah, our mission statement is to help enterprises in adopting the open source technologies. And this includes also not only the functionalities you can have with open source, but also about the non-functional requirements like operability, usability, and all the ETs. One of these ETs is performance, software or application performance. And before going into and explaining to you my journey, which I had with Origoss, I would like to ask again, who knows that person on the left side of my slide? Okay, and keep your hand up if you have seen this video already. No one. Oh yeah, great. The title is misleading. He says that it's really important to focus on non-functional requirements, regardless of what the title says. And I would like to highlight two important messages from this video. One of them is that it's usually much harder to fulfill the non-functional requirements than functional ones. And he also proposes at the end of the video a way to continuously test and assert your application's performance. So it means if you think your application can handle the load of 100 concurrent users, just write a test for that and continuously verify it in your CI. So that's basically the two messages I wanted to take away. But this is not all the things, and I'm not going to replicate the whole video here. This is the theoretical introduction, or putting performance testing into context. So let me introduce you the system under test. The system under test is Corteza. Why I chose this? Because I had to, or my opportunity was to test this low-code platform that we provided to one of our enterprise customers recently, and I had to verify its performance. So I will have a quick demo, but before going into that, I wanted to say that the Helm chart that runs this application is built by our company. It's maintained by our company, and yeah, it's a great way to contribute back our learnings in open source. And I also wanted to say that to set this example pizza application up, it took literally less than 2 hours for me on my local machine, from starting the Minikube or installing Minikube to having the functional application. So that is about the functional requirements. You know, I could meet those functional requirements in less than 2 hours. So let me mirror my screen and click this link. It will open up my Corteza application. There are a bunch of pizzas. There is a pizzas application within Corteza, and here we have a bunch of pizzas. I hope you're not hungry anymore. And what we can do here is we can scroll through these pizzas. We can look at one. It will open the properties page. It's just a dummy application, but yeah, you get the point. And then if I click add, I can provide a name. Let's name it KCD is awesome. Let's choose the whole grain Napoletana for dough. Let's use the tomato basil sauce, and we can choose one or more toppings. Let's use corn only, and let's use mozzarella. And if I click save, that is the functionality. It has created a new pizza. So that is what we are going to test. We have basically three main use cases in this application. One of them is loading this page. The other one is viewing one pizza, and the third one is creating a new pizza. Let's go back to the slide. And I hope it's not full screen, so I have to put it to full screen. Okay, just a sec. All right. So, what are the non-functional requirements? I came up with these non-functional requirements. These are really generous non-functional requirements. So 50 concurrent users. I said that, 50 is the number that my machine can bear. But, in a real-world example, real-world application, you would have much more than 50 users. But with 50, I think you would get the gist of how K6 works. And that was the main reason I decided for this. There are a lot of other performance testing tools like JMeter, Gatling, TestCube, or RunScope. They are good, but I think K6 has the best set of features out of these. So it has a lot of potential, a lot of capabilities, and what's not visible on this slide is really the documentation quality. So I checked documentation and I always find what I'm looking for in the K6 official documentation. Plus, it's really important to say that there is a very strong community around K6. So if you look at the K6 extensions GitHub repo or K6 extensions page, because there are multiple repos, you will find a lot of different contributors building a lot of different extensions, and it's great. It's really community driven. And Grafana is really contributing back to the open source world. So, and also we are using already Grafana in prod, and we are using already Prometheus, so K6 was a natural choice. Let's look at the anatomy of one K6 test. You can see this is written in JavaScript. I tried to fold all the code. I just wanted to say that we have basically 3 exported objects here. One of them is really an object. That's an options object. You can have a lot of options. I'm not going to go through all of those possibilities. What I want to say is that the options have a precedence over each other. So if you specify something here in the test script, in the JavaScript file, it can later be overridden in the CLI flags, for example. Also, we have a setup function, which is the equivalent of the before each in other testing frameworks. So the setup function is running once before the tests, and the return value of the setup function is passed on to the defaulted exported scenario, which is good because then I can acquire the access token, the OAuth access token in the setup, and have our virtual users reuse the same token for each test run. And I also wanted to introduce one concept which is called iteration. So when a virtual user is executing one scenario, one instance of this function, that is called an iteration. Okay, let's move on. I have this slide about the config precedence or options precedence, but I wanted to also show you the Core Pizza test, the Hello K6 Corteza test body. The main thing is in line 49. That is where we do an HTTP request. So let's see this in action. Yep. I have to switch to my terminal, and I'm in the Hello K6 Corteza on our GitHub. This will be public after my talk. I have a hello.js. This is really the file which I've shown you earlier. So if I say K6 run hello.js, it really executed the test once, so there was only one iteration. It printed out the response, the HTTP response. We can see that there are these record references. And we can also see one important thing is that there are metrics about the there are different metrics about the test execution. So you can see the iteration duration, that's an important metric, and you can also see the aggregation of the HTTP requests. So you can see there are statistical aggregations like P95 and so that's about it. That's our Hello K6 test for Corteza or Core Pizza. I hope now you can all write your K6 test after this. Let's get back to the slides because we have a few left. Okay, just a sec. So we are not done yet. We have to simulate the real user behavior. So we can now replay one API request. We can replay it 1,000 times. We can parallelize it to, I don't know, 1,000 users, but that would not test our application, because what happens is that when one user visits the application, there are certain API calls made against our backend, right? And when these API calls are made, there is some timing between these API calls. Some API calls are being run in parallel by the browser, and then there is some rendering, and then there is again some API calls. So we need to replay this. That's one thing we need to solve. I have this on the next slide. So basically what I have there is I highlighted that I want to basically group the requests that are sent in parallel, and then when there's no requests are hitting my API, then I want the virtual user to be sleeping. So that is basically the first part of the problems to be solved. Let's see how I solved that. I wrote a little parser which reads the HTTP archives from the browser. I could export the HTTP archive when I visited the page, so I could just simply click around on the UI and export the HTTP request. And I wrote a simple parser. It's in our repo, which does the grouping, and it also adds the sleeps to the test. So this concept I named flows. So a flow is basically when the user is visiting, for example, one page or creating a pizza. And I have them as scenarios. You can see I have three exported functions, and those three exported functions are basically doing the same thing but for different input. Yeah, it could be simplified, but for this to be clear and understandable, I made some code application. And let's see what's inside our execute flow, which is which is the same for all the three scenarios. We can see that it has an outer for each, and then on line 76 it sends a batch. So what it does is that batch in case 6, it accepts an array of HTTP requests, and then it will replay those HTTP requests in parallel. And I've also added the sleep in line 59. That is basically simulating when the API is not getting any traffic from that particular user. That is there to simulate, for example, when the user clicks around or when the browser does rendering. And okay, we have the scenarios. I just went back one slide. We have the scenarios, we have the execute flow, but how does K6 know which functions to execute? Well, this is where the options come again into play. The options provide us a way to configure, to make it reusable. So I can use the same code base, and I can simulate different constellations. So for example, I can say in this example, I have 50 concurrent users, 15 running the create pizza, 20 running the view pizza, and 15 running the pizza page load. So you get the point. This is how you can have one test execution and run multiple scenarios. This is quite useful because this is what's happening in real life application. But I want to talk a little bit about the executor field, which is there to model the seasonality. So, the traffic is not flat in real world applications, but rather it's changing over time, and executors provide us a way to model this. So there are a lot of different executors. I didn't want to go and explain all of these. I just rather had an index about them. Okay, so we can write our test. Next thing is we need to measure. We need to verify if our application performs well under testing. And we are standing on two legs. One of them is being the Corteza platform. So the Corteza platform is instrumented to some extent. I will show you. And then we need data, the metrics which I've shown in the Hello example. We need also those metrics like the HTTP request duration or the iteration durations. So let's see first the Corteza. For Corteza, we have a lot of telemetry signals, mostly logs and metrics. And we also have infrastructure metrics coming from K8s, CAdvisor. We also have the Postgres database metrics. I haven't told you that Corteza is running on or is using Postgres in my example, but it could use other databases as well. And I've set up the Postgres exporter, and the Postgres is running also in my Kubernetes cluster for the sake of simplicity. Okay, that's it about Corteza. Let's talk about K6. K6 has a lot of built-in metrics. I have shown some of these. These are really the ones that we will be using to evaluate how our application performs and whether it complies or fulfills the non-functional requirement. We have the K6 metrics, but we do not also always want to have those metrics printed out to our console, but rather we want to have them in a centralized location. There are a lot of ways you can integrate K6 with different backends and different visualizations. I chose the Prometheus remote write. The reason is that we are already using Prometheus and we are using Grafana as well. So, but for Prometheus, we need to map the K6 metric types to Prometheus metrics type. This is a more advanced topics, but I want to highlight the native histograms feature. Is there anyone who's using native histograms? No, then I have to explain. So quickly, native histograms provide us a way to more efficiently and more optimally store and query histograms in Prometheus. So, histograms where we have buckets and the different durations are going into different buckets. Native histograms are a better implementation, which is much more efficient and much faster than classic histograms. I think that should be enough about it. We have this dashboard, this performance overview dashboard in Grafana. If we integrate it with K6, we can see a lot of good things. Maybe it's not that visible, so I will try to explain what you can see. The gray line is the number of users over time. The blue line is the HTTP response duration. Right now on the 99th percentile, but you can parameterize a dashboard and it will recalculate the percentile if you change it for 95, for example. And then we have the requests per second. And if we had errors, of course we do not have errors, but if we had errors, that would be also available in red here on this panel. Also on this dashboard, we have the statistics about the HTTP responses. We can see the duration statistics aggregated with different percentiles, and also we can see the status. This is really useful. I'm going to show you how I use this to troubleshoot some issues. Then we have the iteration duration. We saw that how long it takes for one virtual user to execute one scenario. That is the iteration duration. And we have this iteration duration labeled by scenario, so we can see it not in an aggregated, but rather in a pair scenario way, as I said. But we do not have everything. We have our NFR2, which defined the net wait time. The net wait time is basically how long the user is waiting for our system. So it's basically the total execution time minus the sleep. So with custom metrics, I could implement net wait time. Let me quickly prepare the demo for that. So here we go. I hope you can also see it. We have this all four custom metrics. And if I say 011 run, it will run the create pizza scenario. It will run only for 5 seconds, plus a little bit of graceful period. And you can see similar metrics out there, but we also have our custom metrics up here. So it will. There was only one. No, there were 2 iterations. It was slower than when I tested. So there were 2 iterations. You can see the aggregations. 3 iterations. Sorry, yeah, I was wrong. Okay, let's go back to the slides. I have a lot of things to show you, and I want to be cautious about time. Okay, let's move on. I have to talk a little bit about strategy, but this is an opinionated section. This is theory. There are a lot of performance testing strategies, different companies and different teams naming the same things differently. So K6 or Grafana attempts to harmonize this problem with naming. So they introduce their own naming standards to say, and the first strategy I want to talk about is smoke testing. Smoke testing is really a way to check if your application emits smoke when it's under load. Usually you run only a low number of concurrent users for a short period of time. Then we have the average load. So you have to figure out what's the average load of your system. You can use your existing metrics or existing instrumentation to find it out. And it has a ramp-up period, and keep it up for a few minutes or whatever makes sense for your application. Then we have the stress testing. So for a similar duration, but with a higher than average load, and you provide a longer ramp-up time in case you have some dynamic auto-scaling mechanisms in your infrastructure. Soak testing. So normal applications or regular applications are running for a long time. And when I did soak testing, it literally ran for 8 hours. So this is useful for finding memory leaks, for example, in your application. Spike testing, before Black Friday or campaigns, it's useful to run some spike testing with an extremely high load. Breakpoint testing, this is what I did, this is what I will show you here, is useful to find what is the limit of your application. When does it start to throw errors? When does it start to become slow? So let's put this all together. I provided a complete example. I want to just quickly show you the changes in the code. One thing is the thresholds. So thresholds provide us a way to, for example, when we are running a soak testing, we don't want it to run for 8 hours if after 2 hours with an expired token, it starts to throw 100% error rate. That's nonsense. So this is where a threshold comes handy. Also checks, it's there to check functionality. You're mostly using K6 for non-functional requirements, performance, but checks provide you a way to verify if, it responded in 100 milliseconds, but was it successful, or is the field in the response there or not? Then we have the presets. The presets I told you about, these are the different config files that you can use to run the same code base with different number of users. I did some testing on Cord Pizza first with 10 users. We have a quite high wait time, response time. But what is the wait time? The wait time is also very high, so we do not meet our NFR 2. We have with 50 users, we finally have some errors as well. So I went on and troubleshoot this error. Let's see what I found. I clicked around in the metrics and I found something suspicious in the Postgres statistics, which I mentioned earlier. I found that the PG starts are missing when the tests are running. So that is really suspicious. I also checked that the CPU usage was over the limit on my Postgres instance. So this means that the Postgres database was throttled, and you can see it on the curve that after a while it went down. So this is when throttling happens in Kubernetes. So what I did, I converted this to a best effort pod. I also checked which container is using more than, because I have a sidecar for the metrics export in my Postgres. I also checked and it was the database instance, not the metrics sidecar. So I converted this to be a best effort pod, and I got so good results that I couldn't believe. So I ran it twice with 30 users, and the issue was solved, but it was still with 30 users. Net wait time was also under 600 milliseconds, so we fulfilled our second NFR. But with 50 users, I also got some errors. And this is a low error rate, but still, as an engineer, I couldn't stay there and say, okay, that's less than 1%, who cares? So I went on and I like to troubleshoot. So I went on and tried to check what's going on. First, I used the aforementioned panel for the HTTP responses, and I found really a strange situation. So, 99% of our requests are successful, and less than 1% is having a 401 errors, but they are using the same access token. So how could this happen? Some users with the same token are getting unauthorized errors, and others are getting 200s and authorized responses. That shouldn't be the case. So And I had at this point, I had to look at the code of Corteza, but I didn't know where to start. So what I did was I opened up the profiler. Is there anyone who has used profiler before? Okay, there are a few. Great. So, but there, I want to just say what you can see. Maybe it's a bit small, but what you can see is basically a flame graph of the functions and the call stack, how the different functions are calling each other in the Golang application. And if you hover your mouse, I'm using the built-in Go profiler here. If you hover your mouse, it will show you numbers like 10 seconds. It's a 2-minute profile, and it's spent 10 seconds in this validate function, which is part of our authentication call stack. And what I can see is that there's also this verify request. It's quite small, but the verify request checks the access token signature, and the validate goes to the database. So, by the way, I wanted to make another statistic here. How many of you think that a token should be verified more than just the signature? Do you think it should be verified further? Do you understand the question? Yeah. So, yeah, okay. Anyway, Corteza has this built-in mechanism to verify the token also in the database. I checked in the database schema, and yeah, there is this 002 tokens, which could be an explanation why we are getting 401 errors and why there is a higher load. But I was still not sure that this is the case, so I still went on and verified. First, I checked the Postgres dashboard, the official Grafana Postgres dashboard, and I could see that there's a high number of transactions while running the tests, but there's also these idle sessions, and that's quite suspicious. So if you have connections, you might have a connection pool, which could be a reason for the idle sessions. But here, so this red annotation marks when the performance test was running, and after there was no load hitting our API, the connections were still there, still open, and then it went down. So it's not a good behavior. Database connections should be closed, or you should use a connection pool, at least according to my knowledge. So I went on and checked what's up with the database, and I found this fancy log message. So remaining connection slots are reserved for rows with the super user attribute. I checked how many connections are being used, and the peak is at around 70 when the test is running. So I went on and I fixed the issue. I didn't fix the issue, but I changed the infrastructure to be allowing 400 connections instead of the default 100. And then, yeah, the net wait time was below 1 second for 50 users. So we finally meet our NFR, and the issue is still there. So probably we will work together with the Corteza developers and find out if this is an issue or not in their application. But yeah, this is still there, but if we only found it with performance testing. Okay, I have a few slides left. I don't have a lot of time left, so I've tried to be much quicker. What are the takeaways? We could see that it's much easier to fulfill functional requirements, and this is also true when using Corteza. We could also see I'm a coder myself, and to run and maintain a low-code platform, we still need coders. And very important is to learn the failure modes of your application. So you have to know that if your database connection gets saturated, you might get 401s, and it's not the sign of someone trying to hack your system. It might be a sign of your database connection. Performance testing has a low entry barrier, but trust me, there were some advanced topics which required a lot of time for me as well to understand. And then I still want to recommend K6 for anyone to introduce it to your CI pipeline. And yeah, continuous profiling. I don't think I have time to show it, but you can hit me up at our booth, and I can show you the tool which I've also started. This is Pyroscope. I'm not sure that you know it. It's a continuous profiler. So basically the profiles from the CPU and memory can be fetched continuously, and it can be integrated with Grafana. And it supports all those languages: plus eBPF. By the way, I wanted to ask for my personal purpose, who here develops with eBPF? Is there anyone? Okay, I guess I will meet you. I have a few questions. Great. So yeah, Pyroscope. Then there was, it was a funny situation. K6 developed K6 Studio when I had my AJR parser. K6 Studio gives you I really recommend you to check it out. You can record your tests without doing a lot of magic. It opens up a browser, you click around on your user interface, and then it will export the tests. And then you don't have to write your test at all. So yeah, it lacks a few features, but we might contribute back for this and implement those features which I have already. Browser testing, I brought this diagram from Grafana K6 website. I was focusing on the backend time because the front-end time doesn't change with the increase of the concurrent users. So that's why we were focusing mostly. But K6 has a front-end or browser load testing or performance testing tool. If you're interested in that topic, you should go and check it out. Then I didn't work with chaos engineering. It's a really fancy topic. It's really important to learn the failure modes, how your application breaks. And I have a few additional ideas. I wish I could show you the K6 operator, how you can distribute the test, distribute the load between runners. Good thing it was closed. So how you can distribute the load among runners and the operator will spawn different pods. And yeah, that's all I wanted to share here. I hope I was not that bad with the timing. Thank you very much for your attention.